talking about another type of compound event, which is an independent event under theoretical probability. First, what is an independent event? So, an event wherein the previous event doesn't affect the next event is what we do call independent event. If ever that the previous event managed to affect the next event, we call it is a dependent event. Whenever that we are dealing with this kind of event and we are to determine the probability. So for independent event, we use the probability of A and B will be equal to the probability of A times the probability of B. While if the event is considered under dependent event, it is probability of A and B equal to probability of A times probability of B given A. For us to understand this fully, let us have a couple of set of examples. Let's start with the experiment number 1. Number 1. Tossing a die twice. Whenever that you are trying to determine if the event is independent or dependent, you just simply need to understand how the experiment works. So here we are talking about tossing a die twice. If we toss the die once and we manage to get the desired outcome and we're going to toss it again, will the number of total possible outcomes be affected? So a die do have 6 possible outcomes. And if we're going to toss it again, how many possible outcomes we'll have on the next experiment? The answer will remain 6. If we're going to toss it again, it will remain 6 as well. So, upon tossing the die or doing the experiment continuously, the total sample space or the total number of possible outcomes won't be diminished or won't be lessened. So, therefore, all of the probabilities that we will be talking about experiment number 1 will be under independent event, since doing the experiment continuously won't be able to affect the total sample space. So in number 1, probability of getting 2 and 3, so we just simply going to use this formula, the probability of A and B is equal to the probability of A times probability of B. So in a die, we do have a total of 6 sample space. So probability of getting 2 is just only 1 over 6 because we do only have one piece of 2 in a die. While for the second event, getting 3, since we do only have one piece of 3 in a die, so we do have 1 over 6 as well. So based on the formula, we are just simply to multiply these two. So 1 over 6 times 1 over 6. So this will give us 1 over 36. So this is how we do the formula or apply the formula in getting the probability of an independent event. Let's have number 2. Probability of getting an odd number and an even number. So for probability of getting odd number, so the odd numbers from a die are the numbers 1, 3, and 5. So there are 3 pieces. So we have a probability of 3 over 6. While for the second event, even numbers, we do have the numbers 2, 4, 6 as the even numbers. So we do have 3 pieces as well. So we do have a probability of 3 over 6 as well. Then we multiply this now, these two numbers. So 3 over 6 times 3 over 6. So this will give us 9 over 36. But this can be further simplified, and the simplified form for this one is 1/4. So it is as simple as multiplying the probability that we get from each event. Let's have another example. Still with the same experiment, let's have probability number 3, probability of getting a prime number and a composite number. So how many prime numbers are present in a die? So the prime numbers are the numbers 2, 3, and 5. So we do have 3 pieces again. Therefore, the probability of getting prime number is 3 over 6. While for the composite numbers as our second event, the composite numbers only are the numbers 4 and 6. They're just only 2 pieces. So the probability for the second event is just only 2 over 6. So next thing, we are just only to multiply these two numbers. So 3 over 6 times 2 over 6. So this will give us 6 over 36, or in simplest form, we do have 1 over 6. Number 4, probability of getting a number less than 5 and greater than 4. So how many numbers are less than 5 in a die? So those are the numbers 1, 2, 3, and 4. So we do have 4 pieces. So we do have 4 over 6. While for the second event, numbers that are greater than 4, the numbers that are greater than 4 in a die are just only the numbers 5 and 6. So we do have 2 over 6. So based on the formula, we are just to multiply these two, and this will give us 8 over 36, or can be further simplified as 2 over 9. So all the first three probabilities that we solved are under independent event again, because we categorize the experiment to be under independent event. Because upon doing the experiment multiple times, won't be able to affect the possible sample space of the next event. Let's have another experiment. This time, let us deal with experiment number 2, which is drawing a card in a deck of playing cards. So let us first understand how the experiment goes in this one. So drawing a card. So normally, usually, a card or a regular deck of cards do have 52 pieces. So imagine that we are to perform the experiment more than once. We are going to draw a card. So before doing the experiment, we do have 52 pieces of cards. For example, we are done doing the experiment and we managed to get one of the cards. We draw one of the cards. So if we manage to draw one of the cards, upon going to the next experiment, the number of cards will no longer be 52. It will become 51 because we draw one of the cards. And if we're going to have another experiment and we draw one of the cards again, therefore it will no longer 51. It will now become 50. So what I mean is, in this experiment, the number of the total sample space is being diminished. The previous experiment managed to affect the next experiment as we perform the experiment. So therefore, all of the probabilities or event under this experiment will be considered a dependent event. So let us have probability number 1. For number 1, probability of getting a heart and a club. So the number of hearts that we do have is 13. So we're going to have 13 over 52. Before going to the next event of getting a club, we will assume that we managed to get a single heart. So if we're going to get a single heart out of 52 cards, therefore it will now just only become 51. So therefore, we are going to have 13 over 51 since we do have 13 pieces of clubs, and it will now become 51 only because we managed to get a single heart. So that is how we deal with the probability under dependent event. So let us now multiply these two. So multiplying 13 over 52 by 13 over 51 will become 169 over 2652, or it can be further simplified as 13 over 204. By the way, if you are knowledgeable in having the lowest term of fractions, you can apply that. In this case, we can have the lowest term for this part. So 13 over 52 can become 1/4, can be written as 1/4, rather 1 over 1/4. So 1 times 13 is 13, and 4, so that is 4. So 4 times 51 gives you 204. So that helps you in getting the simplest form already of your final answer. Let's have probability number 2. Probability of getting a king and a spade. So the number of kings that we do have on a regular deck of cards is 52. Or rather 4. So we do have 4 over 52. Then again, before going to the next event, on the second event, assume that you managed to get a single king. A king, so a single king only. So from 52, it will now become 51 only. And the number of spades that we do have is 13, so we're to have 13 over 51 as the probability of the next event. Then multiplying these two, so 4 over 52 times 13 over 51 will give us a value of 52 over 2652, or can be further simplified as 1 over 51. Again, if we are good in simplifying, 1 over 52 can be written as 1 over 13. And then we may cancel out this 13 on this side and this side. So what remains now is 1 over 51. And there it is as our final answer of our the simplest form of our final answer. Number 3. Again, keep in mind that this is only a matter of visualizing the experiment. So for number 3, probability of getting a black and a club. So for this one, so the number of black cards that we do have is 26 over 52. Why? Because we do have 13 pieces for each suit. So 13 for the spade and 13 for the clubs. So 13 plus 13. So that's why we do have 26 over 52. While for the clubs, so again, before going to the next event, you assume that you managed to get or be able, you managed to have the first experiment. So we managed to get a black card, just only one card out of 52. Therefore, it will now become 51. Okay. So therefore, for the second event, we do have 13 over 51 as the probability of getting a club. So then we multiply these two. So 13 times 26 and 52 times 51. So that gives us 338 over 2652, or it can be further simplified as 13 over 102. If you are good in lowest term, you may have the lowest term for 26 over 52 as 1 half. Then multiplying 1 half to 13 over 51. So it will give you instantly the simplest form of the answer, which is 13 over 102. Number 4. I want you to listen carefully for this one, for number 4. So getting a heart and a red card. So getting a heart, we do have 13 pieces of heart in a regular deck of cards. So we do have 13 over 52. Before going to the second event, we are going to assume now that we managed to get a heart out of the regular deck of cards. So therefore, it will now become 51. But keep in mind, notice that heart is one of the red cards. So therefore, the number of red cards will also be affected. Thus, we're going to have 25 over 51. So the denominator was affected, or the total number of outcomes was affected, and also the number of red cards. Because heart is one of the red cards. Okay? So that's why here, we have 25 over 51. So simplifying this will give us 325 over 2652, or in lowest term, we do have 25 over 204. Probably you are wondering, what makes number 4 different to number 3? They are quite the same. In number 3, we managed to get a black card. Will the black card be able to affect the number of clubs, since a club is also a black card? The answer is no, not certain, because it is not just only the spade, or rather the flower or the club is black card. The spade is also a black card. So what if the black card that we managed to get is a spade? So therefore, the number of clubs won't be affected by the spade that we got. So that's why here, so there's no certainty that the number of clubs will be affected if we're going to get a black card. That's why it remained as 13. While for number 4, whatever kind of heart that we will get, we are certain that the number of red cards will be affected. So that is the difference. Again, the number of black cards is not certain to affect the number of spades, because the number of clubs, because we do have spades as one of the black cards. But for this one, whatever kind of card that you will get, it is certain that you will be able to affect the number of red cards. Let's have example number 5. Keep on listening. We're going to have a similar probability in number 6. So for number 5, probability of getting a diamond. So we do have 13 pieces of diamond. So we do have 13 over 52. Before going to the next event, probability of getting a club, we will assume that we managed to get a diamond from the deck of cards. So it will now become 51. So 13 over 51. Before going to the third experiment or the third event, we will assume that we managed to get a club. So therefore, that 51 will now become 50. And the number of spade will still be 13. Okay? So there's no effect. Diamond won't be able to affect the number of spades if we're going to get a diamond. And the number of clubs won't be able to affect the number of spades. So that's why we still have 13 here. So upon multiplying all of these three, so this will give us 2197 over 132,600, or can be further simplified as 169 over 10,200. Let's have number 6, last example under experiment number 2. Listen carefully. Getting a red card. So before getting a red card, so we do have here 26 over 52, because we do have 13 pieces for the diamond and 13 pieces for the heart. Next one is getting a spade. So the number of spades, so before going to the next for this event, we assume that we managed to get a single red card, only one red card on a deck of cards, therefore it will become 51. So 13 over 51, since we have 13 pieces of spades. Next one, before going to the third event, we will assume again that we managed to fulfill this experiment and we managed to get a spade, a single spade. So therefore, it will now, the number of cards that we will have is just only 50. Now, if we're going to get a spade, will the number of black cards be affected? The answer is yes. Certainly, the number of black cards will be affected because we managed to get a single spade. So therefore, the probability for the third event is 25 over 50 because the number of black cards was affected because of a single spade that was taken. Okay, so hope you understand how or when the numerator changes with the experiment. So multiplying all of this 3, so this will give us 8,450 over 132,600, or can be further simplified as 13 over 204. So hope you understand how to deal with dependent event. Learn to visualize the problem, understand how the experiment goes. Let's have experiment number 3. Experiment number 3, still drawing cards in a deck of playing cards, but this time with replacement. When we say with replacement, after performing the first experiment, after getting or drawing the first card, you are to return it again. So meaning, if we do have 52 cards, and we get one of the cards, then before going to the next experiment, we return the card that was taken. Therefore, the number of total sample space will still be 52, or it will remain returned to 52 because we are replacing the card that we have taken or that we have drawn. So let us now have the following. So therefore, for experiment number 3, this is under independent event because the number of the total sample space remains the same or not affected by the previous event or experiment. So for number 1, probability of getting a heart, so we do have 13 pieces of heart, so we do have 13 over 52. Since experiment number 3 is categorized under independent event, therefore the denominator won't change. So for the number of clubs, so we still have 13 over 52. So we just simply multiply these two, giving us 169 over 2,704, or can be further simplified as 1 over 16. Good in simplifying and having the lowest term. This can be written as 1/4. Same as this one. This can be written as 1/4. So 1/4 times 1/4, that gives us 1 over 16 instantly as our final answer. Number 2. Probability of getting a king and a spade. The number of kings that we do have is 4. So we do have 4 over 52. Again, upon going on the next experiment, keep in mind that experiment number 3 is under independent. Therefore, it will still be over 52. So 13 over 52 because we do have 13 spades. Multiplying these two, we do have 52 over 2,704, or the simplest form is 1 over 52. Again, the total sample space on the next event wasn't changed because we are replacing what was taken. Number 3. Probability of getting a black card and a spade. So the number of black cards is 26. So 13 for spades, 13 for clubs. The number of clubs is 13. So we have 13 over 52. So keep in mind, under independent event, we are not, the previous event doesn't affect the next event. So we multiply this. So we do have here 338 over 274, or simplest form is 1 over 8. Number 4, probability of getting a heart and a red card. So the number of hearts is 13 over 52, while the number of red cards is 26 over 52. Then multiplying these two, this will give us 338 over 2704. We need to have the simplest form, and the simplest form is 1 over 8 as well. So let's have last experiment. Keep on listening. Experiment number 4, drawing a card. So getting a single card and tossing a coin. In this case, we do have 2 separate sets of items. So if you encounter this kind of experiment, automatically you will be considering the experiment to have independent event. Because if you draw a card, the total sample space of the coin won't be affected because they are two separate items. So this is still under independent event. If we draw a card, the total sample space of the coins will remain 2. So for the coin, we do have 2 total sample space because of the head and tail. So for the card, we do have 52. So let's have the following probabilities. Number 1, probability of getting a black card and the head, the number of black cards. So we do have 26 over 52. So if we are done getting the black card with the number of possible sample space of the coin upon tossing will be affected, the answer is no. It will remain as 2 because they are two separate items. So we do have 1/2 because there's only one head in a coin. So multiplying this 2, this will give us 26 over 104, or in simplest form, we do have 1/4. Number 2, probability of getting a heart and a tail. The number of hearts, we do have 13 over 52. The number of tail from a coin is just only 1. So 1 over 52. So multiplying this 2, it will give us 13 over 104. Or in simplest form, we do have here 1 over 8. So that's how simple in computing probabilities. Experiment number 4, probability number 3, getting a face card and a tail. So for the face card, we do have 12 because of the jack, queen, and king times 4 different suits. That's why we do have 12 here. Then for the number of tails, we just only have 1 still because we're talking about coin. So 12 over 52 times 1/2. The answer is 12 over 104. And the simplest form is 3 over 26. Last, number 4, probability of getting a club and the head. So the number of clubs that we do have is 13 over 52. And the number of head from a coin is just only 1. So 1 over 2. Multiplying these two properly, this will give us 13 over 104. Or in simplest form, we do have 1 over 8. So hope you understand how to determine the probability of events under independent event or dependent event. Just keep on analyzing how the experiment goes. Will it be able to affect the universal set or not? So, thank you for watching. So, hope you learned something. See you.